This video is about evaluating a function in function notation and identifying a dependent and independent variable. So before we get to that, we need to know what a function is. So a function is a relationship between two quantities in which one quantity is associated with a unique value of another quantity. So what that basically means is for every input in our function, we're going to have one output. So for example, if we said x was 5, there'd be one y value that'd be assigned to it as the output. So let's look at the vending machines to talk about functions a little bit more. So which vending machine represents a function in y? So if we look at the vending machines, we have two different ones. We have a refreshments and a cold drinks. So in the refreshment, if I press button A, I'm getting orange juice, B is apple juice, C and D are skim milk, E is chocolate milk, and F is water. If I look at the cold drinks machine, A is orange juice, B could be apple juice or skim milk, C is skim milk, D is chocolate milk, E and F are water. So the difference here is this button B, which makes it a function or not a function. So remember that we need to have a unique value. So every time that we do an input of pushing the button, we need one output that we can expect to happen. So this one, the refreshments machine, is a function because each button is assigned one output. And the output here would be our drink choice. So it's okay that some of the buttons like C and D are going to the same drink. That's okay because we know though if I hit the button, I know I'm getting skim milk. So which one is not a function and why not? The cold drinks would not be a function because we don't know what drink we're going to get because it has two output values. So we would say cold drinks is not a function because button B has two outputs or two different drinks. So let's evaluate now using function notation. So up here in this box we have three different functions. We have f of x equals 3x squared plus 5, g of x equals x minus 11, and h of x equals negative 5x minus 3. So what we're going to do is we're going to use the letter to tell us which function to use. So if this is f of 10, we're going to take 10 and we're going to substitute that into the x in the f equation. So the letter outside tells you which equation to use, and then the number inside the parentheses tells you what to substitute in for x. So when we substitute, we have 3 times 10 squared plus 5. So remember, whenever I substitute, I'm going to put that number in parentheses. So now it's just order of operations. 10 squared is 100, so we have 3 times 100 plus 5. 3 times 100 is 300, plus 5 gets us 305. In number 4, g of negative 22. So this time we're going to take negative 22 and we're going to substitute in for x in the g equation. So when I substitute, I have parentheses negative 22 minus 11. So negative 22 minus 11 is negative 33. Number 5, we have 3f of negative 5. So we're going to put negative 5 in for x still, but because this negative 3 is there, we're going to put that in the outside in parentheses. So we're going to do 3 bracket, and we're going to do this in the bracket. So 3 times negative 5 squared plus 5. So with order of operations, we have to do that grouping sign first and leave the 3 on the outside. So we have 3 times negative 5 squared is 25 plus 5. 3 times 25 is 75 plus 5 gets us 80. So now 80 came out of the parenthesis, and we're going to multiply with that number we had in front, which is called the coefficient. So 3 times 80 is 240. So let's try that again with the h equation. So we have h of 0. So we're going to take 0, and we're going to substitute in for x in the h equation. And then we have a negative 2 out front. So we're going to do negative 2 bracket negative 5 times 0 minus 3. So negative 5 times 0 is 0. Minus 3 gets us negative 3. So we now have negative 2 times negative 3, which is 6. Let's look at some more function notation evaluation. So now we have two functions and they have operations with them. So we have v of 5 plus w of 2. So we're going to take 5 and we're going to substitute for x into the v equation, and we're going to take 2 and substitute for x in the w equation. So I'm going to rewrite these separately. And I'm going to do brackets so I can group each one together. So we have negative 3 times 5 plus 11 plus, and then we're going to do the equation for the w, which would be 2 squared minus 2 times 9 times 2. So we're going to evaluate each of those separately. So in the first equation, we have negative 3 times 5 is negative 15 plus 11 gets us negative 4. And then we're going to bring down our plus sign from the middle. And in the other equation, we have 2 squared is 4 minus 9 times 2, which is 18. And that gets us negative 14. Because 4 minus 18 is negative 14. So now we have negative 4 plus negative 14. So we can combine those together to end with negative 18. Number 8, when I substitute, I'm going to put negative 3 in for x in the v equation. And I'm going to put 4 in for x in the w equation. So when I rewrite this, I have negative 3 times parenthesis negative 3 plus 11 minus parenthesis 4 squared minus 9 times 4. So notice that each function right now is in a bracket, so I do that whole function by itself first. So negative 3 times negative 3 is 9, plus 11 gets us 20. And our other parenthesis, 4 squared is 16, and negative 9 times 4 is negative 36, which gets us negative 20. So we're going to bring that subtraction sign down, and then we also have a negative 20. So in this case, we have 20 minus negative 20. Remember, two negatives make a positive, so this will become 40. Now in number 9, we have to do operations with our functions, and we have coefficients in front of them. So in number 9, I'm going to have 3 parenthesis, negative 3 times negative 4 plus 11, minus, and there's nothing in front of the w, so we just have our bracket, negative 5 squared minus 9 times negative 5. So I'm going to evaluate each of these functions separately first. So the first part, negative 3 times negative 4 is 12, plus 11 is 33. So we have 3 times 33, which is 99, minus, and we're going to do the other bracket. So negative 5 squared is 25, and negative 9 times negative 5 is 45. So we're going to add that together, which gets us 70. So we're going to have 99 minus 70, which is equal to 29. So let's try one more example of the function notation then. So in the first one, we have negative 4v to the 11th. So we're going to put 11 into the v equation. For x, we have negative 4 bracket 3 times 11 plus 11. And then the second equation, we have plus 2 bracket 20 squared minus 9 times 20. So in the first equation, 3 times 11 is 33, plus 11 is 44. So we have negative 4 times 44, which is negative 176. With our second equation, we're going to bring down this plus 2 for now. So 20 squared is 400. Negative 9 times 20 is minus 180. So we have 400 minus 180, which is 220. So we have 2 times 220, which is 440. So then I have negative 176 plus 440, which gets us 264. So the other thing we're going to talk about in this video is variables. So with variables, and you've heard this probably in science class before, is we have two different types of variables. We have independent variables, which are variables that do not change based on other variables. So the most common example of an independent variable would be a unit of time. So minutes, hours, days, years, etc. The other variable is a dependent variable, and this variable changes based on another variable. So some examples of those could be money or distance. So let's look at writing a dependency statement and writing the independent and dependent variable. So we're going to start with a function rule. So we have y equals 3x minus 9. So we have the dependent variable, which is the output, and we have the independent variable, which is the input. So remember, in a function, you're given an x value, and it could just be any random number picked. So that's going to be our independent variable. There's no act from the y to change what the x is. Then when we put in the x, our dependent variable is going to be the y, because that's the output we're getting out of the situation. So let's look at some things with some variables with words now. So the number of calories you burn depends on how much time you work out. So remember, independent variable is something that you can't change. It's not changed based on another variable. So in this time between the two things, it would be the time you work out. So the dependent variable is going to be the number of calories you burn. So in number 12, this is an example of a dependency statement because we have the depends on in the front, in the middle. So whatever comes before the depends on, that's going to be our dependent variable. And whatever comes after the depends on is going to be our independent variable. So in 13, we need to do all of it together. So we have the time driving versus the distance traveled. So in this case, our independent variable, remember, is going to be the time because we can't change that. So time driving, because time is going to happen no matter what. And the dependent variable then is the distance traveled. So our statement then is going to be the distance traveled depends on the time driving. So let's look at another example. Number 14, number of songs you buy in iTunes versus your iTunes bill. So remember, anytime there's money, that's going to be a dependent variable. So we have the iTunes bill. And that's changing based on the independent variable, which is going to be the number of songs you buy. So when we do our dependency statement, remember, it's dependent variable depends on independent variable. So your iTunes bill depends on the number of songs you buy.